Hello and welcome to another video. Today we will be learning about vector applications. One of the most common applications for vectors is going to be dealing with velocity. So just so you know, the magnitude of any velocity vector is always going to be the speed. Remember the difference between velocity and speed is that velocity has a direction. Speed is just going to tell you how fast the object is going. Keep in mind that difference. If we remember, the component form of a vector is going to be equal to its magnitude times the cosine of the angle of direction, comma, its magnitude times the sine of the angle of direction. Keep that in mind. It's going to be important when we start looking at problems. So looking at the first problem, during one part of its migration, a salmon is swimming at 6 miles per hour, and the current is flowing downstream at 3 miles per hour at an angle of 7 degrees. What we're trying to figure out is how fast the salmon is moving upstream. So the current is going to affect the speed of the salmon. So even though the salmon is outputting a force enough to move at 6 miles per hour, the current is going to push it down, making it slow down. And it's actually now moving at 6 miles per hour is going to be less because of the force of the stream. So I'm going to underline some important information. I am going to be underlining the 6 miles per hour that the salmon is swimming. I'm going to underline the 3 miles per hour from the stream. And then I'm also going to underline the upstream, meaning it's going up, basically to the north. And then about the current that is flowing downstream at an angle of 7 degrees. The first thing that I'm going to do is I'm going to draw a little chart, and then I want to plot where my velocity vectors actually are. So first I'm going to do the red one, which will represent the salmon going upstream, and I'm going to call that vector S. The second one, I will do it in green, which will be the current, and the current is flowing downstream at an angle of 7 degrees. So I can actually put it here and then say that this angle 7. I can also put it on the other side because all they want to know is the actual velocity of the salmon, which is doesn't going to change, but I'm just going to put it there. And then I'm going to call that second vector C for current. So I have two vectors, the red one, which is vector S for salmon, which will be equal to, again, remember the magnitude, which will be the speed, which will be 6 miles per hour, times the cosine of the angle of direction. Again, angle of direction starts on the positive x-axis, goes counterclockwise, so that would mean that this angle is 90 degrees, comma 6, which is the same speed, times the sine of 90 degrees. Now I'm going to write my vector for the current, or vector C, which will be equal to its speed, which in this case is 3 miles per hour. I underlined it at the top, times the cosine of the angle of direction. Again, angle of direction, so this will be 90, 180, 270 plus 7, which will be 277. That looks ugly. Let me erase that really quickly. 277, comma, again the speed, which is 3, times the sine of 277. Since we are trying to figure out how fast the salmon is actually moving, I have to add up the two vectors together to figure that part out. So I'm going to do S plus C and get a new vector. So what I'm going to do is I'm going to add the component, A component plus another A component to get my new one, and then the B plus B to get my new one. So when we're talking about forces or velocities, we're actually able to add them together. So in this case, the new vector will be 6 cosine of 90 plus 3 cosine of 277 I'm just gonna erase this real quick. Give me a little bit more space. So again, 6 cosine of 90 plus 3 cosine of 277. Again, all I did was add my two a's to get a new a, and add my two b's to get my new b. 6 sine of 90 plus 3 sine of 277. Giving my new vector, so I'm just going to go to my calculator, make sure you are in degrees, which I am. So 6 cosine of 90 plus 3 cosine of 277. And then I'm going to get a decimal, and then I'm going to repeat the steps for the sign. So I'm just going to copy this, since it's going to be the same thing. I'm just going to replace that with sign. I'm going to do the same thing for the second one. And get it as a decimal. I'm going to round to the nearest 1,000 just to make it easier and I don't have to write the whole thing. So that'll be 0.366 for A. And then my B is going to be 3.022. After I add them up together and I have the resultant vector of basically the addition of the two vectors that I'm working with, all I have to do is find the magnitude of the new vector, and then that will tell me exactly how fast the salmon is moving, because it's putting enough force to move 6 miles per hour, but then the current is pushing it down. So it's actually not going to go 6 miles per hour, it's going to go a little bit less than that, or less than that, depending on how fast the current is flowing downstream. So remember, to find the magnitude, all we have to do is a squared plus b squared and take the square root of that. So I'm taking the square root of 0.0366 squared plus 3.022 squared. So I'm going to do that in my calculator. Okay, so again, we're doing 0.366 squared plus 3.022 squared. Get my answer, and then don't forget to take the square root of that answer to get your final answer, which will be 3.044. So that will be equals to 3.044. Don't forget your unit, which would be miles per hour. Let's look at some examples with forces. So on this one, it says that you have two forces. One of the forces is 35 pounds. The other one is 50 pounds, and they're acting on the same object. The angle between the forces is 30, so that's going to be an important part. And then we're trying to find the magnitude of the resultant vector of these two forces. So what I'm going to do to help me, I'm going to draw a little chart. And I'm going to draw one of the vectors right along the positive x-axis. That way I don't have to find the direction for it, angle of direction, because it'll just be 0. So I'm going to call one F1 for force 1, and I'm going to call the other one F2 for force 2. So I know that the first force is 35 pounds. And then I know that the second one is 50, but there's angle in between them that's 30 degrees. So just follow pink. 30 degrees, and then again this one is 50 pounds. So when we talk about the forces, basically it's going to be very similar to the other one. The magnitude is the force applied to the object, and then the theta is going to be the angle of direction in which the force is being pulled. So I'm going to call this one F1 at the bottom, and then this one F2 at the top. So for F1, the magnitude will be 35 times the cosine of 0, like I said, because it's just along the positive x-axis, but you can actually place it anywhere. And then 35 sine of 0. So that will be my first one. For my second one, it's going to be 50 for its magnitude, cosine of the angle of direction, which in this case is 30 because we're just going 30 degrees counterclockwise, comma 50 sine of 30. So I'm going to do the same thing. I'm going to add them together since I just want to find the magnitude of the resultant force. So that will be 35 cosine of 0 plus 50 cosine of 30, comma 35 sine of 0 plus 50 sine of 30. Of course, it will look a little bit nicer once I put in the calculator.
So 35 cosine of 0 plus 50 cosine of 30 degrees. I'm going to get my first A, which will be 78.301. Comma. Then I'm going to do the same thing for the B's. So when I add my B's, I'm going to do 50 sine, sorry, not yet, 35 sine of 0 plus 50 sine of 30. And then that will give me the answer of 25. I'm going to put it there. Now all I have to do is find the magnitude of F1 plus F2, which will be the square root of 78.301 squared plus 25 squared. And I'm going to put that in my calculator and get my resultant force. So 78.301 squared plus 25 squared. Once I get my answer, don't forget you have to take the square root of it because you want to do the square root of a squared plus b squared. I'm going to go up and copy. And then my final resultant force will be 82.195 pounds. So our final answer will be 82.195 pounds. Don't forget to put your unit. And we are done with this problem.
So now you have two kids pulling the leash on a dog, and then they're telling you that the girl is applying a force of 23 pounds. The boy is applying a force of 27 pounds, and then they show you the diagram for the angle of direction, basically. That's what it's used for. So I'm going to call the first one J. I'm going to call one of the vectors vector J for Juana, and the other one vector D for Diego. So Juana is applying a force of 23 pounds times the cosine of the angle of direction, which in this case, what you can imagine is that you create a coordinate plane right here. And then for vector J, your angle of direction will be 18 degrees, comma 23 sine of 18 degrees. And then for vector D for Diego, the magnitude will be 27 because that's how hard he's pulling, times the cosine of the angle of direction. I'm going to bring back my coordinate plane because this is where it's going to change a little bit, because now you're moving from here all the way until there. So it will be almost a whole rotation except for 15 degrees. You're 15 degrees short. So what I'm going to do is I'm going to do 360 minus the 15 degrees that I'm short from doing a full rotation and figure out that this angle is 345 degrees. So 345 will go here, comma 27 sine of 345. Again, all I'm trying to figure out is what the vectors for J and D are, and then use those vectors to figure out how hard they have to pull in order to keep the dog from not moving at all. So basically what's happening is that the kids are applying the same force as the dog in order for nobody to be moving. So if we figure out what the magnitude of J plus D is, we will be able to figure out how much force the dog is applying in order to keep them still and not move. Okay, so I'm gonna add them together, so that'll be 23 cosine of 18 plus 27 cosine of 345, and then I will do the same thing for the sines, comma 23 sine of 18 plus 27 sine of 345. Put that in my calculator. So 23 cosine of 18 plus 27 cosine of 345. Cosine of 345. And to get my A, and then I'm going to repeat the same thing but with sine to get my B. 23 sine of 18 plus 27 sine of 345. So now I know that my A is 47.954. 47.954, comma 0.119. Again, I have to find the magnitude of J plus D, and then in this case that will be the square root of 47.954 squared plus 0.119 squared. I'll go to my calculator, square root of 47.954 squared plus 0.119 squared. I get my answer of 47.954 pounds. And that will be my final answer. Thank you for watching. Don't forget to subscribe and like the video if you haven't. See you next time.